Hello friends, this is Rupesh and I'm watching CVP Nuts video series on data structures, and this topic is linked list. Don't think that this is very silly topic. So there are so many things you can actually do with the linked list, and this is a video where we will discuss little notes and what are the operations we can do with the simple linked list and what are the pros and cons and type of the linked list. I have not listed one more type here. I would like to surprise you with that. Linked list is a very sophisticated topic because it is a dynamic memory allocation technique. It can create a dynamic memory and it handles your data dynamically. It is not a static thing. This is a dynamic thing. That's why it is really very important. So take it very seriously. So let's start this. So the note says that this is a sequential data structure and is used to store data. Obviously, this is an obvious point here, but the point is it is a sequential data structure. Don't miss this point. If someone asks you and you are a beginner, you should be knowing this. This is a sequential, and linked list is a spatial data structure in which data elements are linked to one another. Let me draw a diagram for you if you don't know how a linked list look like. So this is how your linked list actually look like. There are these memory blocks which actually store your data. So this memory block is nothing but a combination, and this is a single linked list. Okay, so don't get confused with so many linked list types here. So this is your linked list, and this is going to contain your data, and this is going to contain your next node address. Okay, and this is a node here. So if you remember array, which you sure be remembering, I don't know why did I said that, some maybe 7 or 8. In array, this is also a sequential data structure, and in array you don't remember that what is the next memory location, right? You just say 0 1 2, and if this is ARR, you will say that okay, ARR of 0 or maybe ARR of 5. Okay, but in linked list you cannot do that. I'll come to that later. What I mean to say is you don't, or this guy don't have to do anything with this guy. It is not saying that okay, I am storing some information which will actually take me to the next guy. No, this is sequential. This will be like a house number. Someone visits your house and next to your house is obviously more, next house number is greater than your number, or maybe if you are this guy, then your previous house number is less than your house number. Okay, so less than means by 1, and next is incremented by 1. So this follows a house numbering or some sequential numbering, but this does not follow. As you can see that, see what happens is there is a pool of memory here with your operating system. Let me just go through that so that people will understand it better. So this is a memory pool, and where is this? This is with OS. Now let's suppose you are asking an array. You are creating an array integer ARR of 5 size, let's say that. Then what this is doing, it is taking some memory of 5 size. Let's suppose this is 0 to 4. Just assume that. Okay, so you have taken 5 memory blocks of integer size for you, okay, at one shot, correct? Now let's come to the linked list. When you create a linked list, you don't say that okay, I want these many blocks. You just simply create by one block. So what happens, you or your program will ask this memory pool, dude, give me one memory block, and if that memory block is of integer type, it will give 4 bytes. Okay, so let's think that it is taking this much and it will return, and let's suppose this guy was returned here. Now after some time, and wait a minute, we're talking about the construction of the linked list. Okay, so after some time you realize that okay, I need another element in my list, and let's suppose this is your full list. Initially how to say that, just forget about 2 3 and 4. Just assume that you have only this one right now. Okay, so you created this list, and how did you create it? You asked 4 byte of memory because your data type was integer, correct? Now when you need another element to be stored in your list, what you will do, you will again ask to the OS, please give me some memory. maybe this time OS will give memory from here. So can you see this? This is actually not in sequence how it was in array. Okay, so this is actually going to be this one, and this time this is coming from here, not just after this, because it depends on OS and fragmentation and lots of stuff comes into the picture. Or the simple point is it won't be adjacent to each another. Okay, so this can be 0 cross 1 1, and this can be 0 cross maybe something, I don't know, but it is not just after this like array. So this is how it works. So next time you'll ask for this element, then it will create maybe somewhere here, I don't know, and it will return to you. So can you see this? This is very important. Okay, concentrate. In linked list, you do not take a full chunk of memory in the beginning itself. You don't specify like this. In array, you have to specify, but in linked list, I'll show you how to create this. I have a program for that. But just assume that whenever you want to use some space to actually store your data. So see, this is your data. So 1 is your data. So there is a possibility that your algorithm or whatever you are using, maybe right now you have only a few data, maybe 1, 2, and 3. So why to have very big memory chunk to actually store 1, 2, and 3 and rest will go waste? No, that is not a good idea. And generally it is not good idea when you are working in some embedded company and you have limited resource of memory. Okay, so that is not a good idea. So what we do, what they do, they really don't like array. I'm telling you, they like linked list like anything, because the freedom is not only this, you can ask whenever you need. Actually, the freedom is you can delete whenever you need. Okay, you can delete at any position, and that much memory block will go back to the memory pool, and that memory can be given to somebody else or to your program only for some another reason. But if you would have used array, you are actually holding that big array, and even if you are using just maybe 1 or 2 or maybe 10 elements of that, and maybe you are holding 1000 size array, so that is not a good idea. So best part is whenever you need, you can get it. And another best part is whenever you don't need that, you can return that memory, you can free it, and then it will go again back to the memory pool. That is clear? Now let's come back to our notes here. So we have covered this second point. It is linked with each other. Obviously the pictorial look of the linked list is okay. I have showed that. Operations linked list provide you insertion, deletion, traversing, and update also. So you can update the elements. What I mean is you can actually traverse and come to this place and make this 3 as 30. Okay, so that is also possible. So that is update. Okay, so we have talked enough about the linked list. Now let's look at the pros. Shall we do this or shall we see the program first? First I would like to show you program, then we'll see about this. So the program is like this. This is your linked list data type. So see, I have given this linked list as linked list name. This is very obvious. You can have given sub node, but I thought, okay, if someone is very beginner, they will be confused what is node, what is linked list. So I just given the linked list as name. So struct linked list. I have created this linked list in the form of C++. So don't get confused. I'm using new here. Okay, you can go ahead and check how to implement this linked list in C program if you are interested. But wait a minute, let me just complete all these things, then you go. Okay. Okay, so as I said, you need data and the next. So this is how your structure look like. So this is one box, okay, what I showed you before. So this is one box, contains data and the next, and this is just print linked list sum function. The main idea is this: I will be using 3 nodes, root, second, and third. Oh, and I don't wanted to show you this right now. Sorry for that. Don't pause and go back. Okay, I'll discuss about that. Don't worry, just concentrate here right now. So as I said, we'll be having 3 nodes. So this is going to be your first node, this is your second node, and this is your third node. Okay, and this we call a head, and this is like 2 portions. First we will store 10 here, I wanted to give you a pictorial representation of my code, what I'm doing here, okay? And this is your null. And this is nothing but this one, and this is nothing but this one. So actually this is your root, this is your second, and this is your third. I told you, right? We create memory for each and everything, and we actually ask to the memory pool and it will give you back. So can you see this? Root is asking new linked list. So if you are familiar with the C++, I'm so sorry. If you are familiar with the C++, you will be knowing that this is a dynamic memory allocation. It will take memory from dynamic pool, which is nothing but a heap. So, okay. It will take memory from this pool. For simplicity, for now, it will take from this memory pool, okay? So we are taking 3 memories from this memory pool here. After taking the memory, you are setting your data part. As this is a pointer, we'll be using this arrow notation. Data is 10, roots next is second. So actually this next, so this is your data portion and this is your next portion. So this next is actually pointing to this one, means actually it is holding this second. So maybe this is 0 cross 1 2 and this is 0 cross 0 1, maybe 0 cross I don't know, 4 0, I don't know, but yeah, sir. So here actually you have this 0 cross 12 here at this location, and at this location you have this one, and at this location you have nothing, you have null. So when you will go by hop and you will reach this node and see that okay, next is null, then you will understand that okay, list is empty. So let's recap why we are learning this linked list. I'm again going back to this one. See, you have 2 major data structure. This is array and this is your linked list. So when you are using array, you don't have any option that you can return unused memory blocks. Okay, maybe initially, let's suppose there is some algorithm which needs, maybe initially it needs let's call it a 10,000 elements of integers, and what you ended up, you created an array of this array of 10,000, and that's what you did. And after some time this algorithm will no longer need this 10,000, you know, it will maybe need maybe some 100 elements, and then it may go from 100 to 200 max, you know that. I mean, it's your algorithm, it's your program, it's your system. You would always know that it is not going to go more than 200 elements. So what is the good way to actually achieve this? You will directly use this array and you will just close your eyes and you will forget about those 800 wastage. Or what you will do, you will create a linked list, I mean like this. And you know what, actually this is just a simple implementation. Linked list is little tedious than array because you have to do the memory management and all that stuff. So if you don't want to use this 10,000 array here, then you should go for the linked list. And linked list will cause you to write little bit more because you have to take care of returning unused memory and asking from OS to give you the memory and pushing the data to the memory, maintaining this particular next to next and next pointers. So you will have to write a code for that actually. But if you're taking array, you're done. You're literally done. But the problem is you may end up wasting so much of memory. So that's why when you have scarcity of memory, you will go for linked list. It is just a simple solution. And wait a minute, not only this, let's come to another point. This was a memory efficient point. Let's go to pros and cons and we'll understand this topic a little better. So the pros are, linked list is dynamic data structure. It can grow and shrink at runtime. Yes, this is a plus for the linked list. It is used to efficiently utilize memory. This is another plus. I gave you the example, right? If you use array, you will waste memory. If you don't need that, you cannot return that memory to the memory pool, right? So you ended up having that much memory, and that is a wastage. So this is plus insertion and deletion is very easy at position. Oh, sorry, any position. Exactly. Let's come to this one. Let's suppose you have this 1, 2, 3, 4. What if I want to insert maybe 10 here? So I want to make it look like 4 and then 10 and then 5, 6 and 7. So I want to insert something in between 4 and 5. Can I do that without actually shifting all these things to right? I mean, I have to literally copy 5 into this place, 6 into this place and 7. Let's assume we have another place and 7 here. Okay. So now we have the room here and then we will write our 10 here. Getting my point? So there is a very big move, and the time complexity of that move you can consider n, because maybe you are inserting at the first position only. But come to this linked list world, if you want to insert something here, what you will do? You will create another node. So instead of pointing here, now you will start pointing this guy will point this guy, and here you are inserted 10 and you are done. So how many changes? One change and second change. So maybe 2-3 operations and you are done. But here you had to move a lot. Okay, so that's what another problem with the array. But in linked list you are crisp here. Okay, so let's go back. Okay, fellas, so this was another third point. There are so many pros here. I have listed them in later section, so it will come in 2 minutes. Wait for that. Okay, so cons are like more memory is required if list is very big. Did someone thought about it? What I mean is, in first place I'm saying that it is a efficiently utilize memory. I mean, you will use linked list when you want to efficiently utilize your memory, and that was in pros. And in cons I'm saying that more memory is required if list is too big. So here I'm saying it will take less memory, here I'm saying it will take more memory. Did someone thought about it? I don't know. Okay, if you did, let me know in the comment section. So what I'm telling is, let's suppose you want to create an array of maybe 100 size. This can be very big. For simplicity I'm taking 100, and let's suppose there is a linked list which is also I should not make this blocks, but I'm saying okay, it is like a size is 100. I mean, this linked list also have 100 elements. So what do you think? Which one is actually occupying more memory space? Actually this one. Why? Because linked list, one data contain two information, data plus next information, whereas in this array you have only data part. You don't actually store what is your next, but here you ended up storing what is your next. So this comes with the penalty when you have a very big linked list. So in this case, how much wastage is there? And if it is 100 cross 8 bytes, considering this address will take 8 bytes of memory, which it generally takes nowadays. So you are wasting 800 bytes if you are going to use linked list instead of array. So now you might be thinking, why should I go for array now? Linked list now, because this is a dumb data structure. It will waste so much of my memory. But wait a minute, guys. The initial rule of linked list is, dude, don't use me unless you really need me. So it is like you are always going to have 100 elements in your program, then go for array. That is the best thing for you. But maybe sometime you will have 1 or 2 or maybe only 5 elements in your program, then don't go for array, because you will end up wasting so much of memory. So it depends on your requirement what you should use. And there are so many things where you cannot use array like tree, graph and all that, they are actually based on linked list. So we'll see that in next points. Okay, so we have talked about this point here. More memory is required if list is too big. Correct. So this is not good. So accessing element is time consuming. Let's talk about this one, guys. As you have linked list and I said it can be very big. Correct. So if your array is like this, where it have 1 2 3 4 5 6 7 8 elements, and similarly let's assume you have a linked list and this is here and this is here. Okay, and this is your head. Oh, wait a minute, I did not show you, right, that how this traversing work. I'm so sorry, guys. Let me show you the program first. So I give this root and asked print linked list function to actually print it, right? So what I'm doing in while loop, I'm checking that if root is not null. So this is one of the way to actually check whether it is true. If it is true, means it is not null. So if root exists, I'll print root data and root will become roots next. So now initially it was pointing to the first element. Now it is actually pointing to the second element, and I'll go further in the loop. Okay, second element exists. Yes, it does. So I'll print data of second element and I'll make root as third element, because now second element's next is actually pointing to the third element. So like this, you have to go and iterate one by one to this linked list, this one or this one. But come back and see this. You had to actually loop through each and every node. What if I'm telling you I want fifth node? So this is first, second, third, fourth, fifth. So if I want this one, what you will do? You will loop through 5 times and you will reach to this guy and return this 5 to me if you are using linked list. Because as I said, we are discussing about this point. Accessing element is time consuming. So if it is linked list, you have to actually go to that place to know what is the element at that, and it is a very time consuming. All the time you have to start from the beginning and reach to the element, beginning and reach to the element. But in array you just simply write ARR of 5. It will give you that element in order of 1. I mean, it will just take one attempt to get that element for you. But in linked list, it will take order of, let me write that, order of n, because you might be asking the number which is in the end. So it will have to traverse each and every node to actually get this one. So the traversal take time, and accessing elements takes time in linked list, whereas in array it is very easy. Can you see? It is so interesting. I mean, one side you have faster but memory wastage, and another side you are having a good memory management at some point, but you are dealing with little bit slower system. So there is always a trade-off between, if you know computer science very well, there is always a trade-off between speed and space. Okay, how fast you can go and how memory efficient you can be. So there is always a trade-off. If you go higher on this, sometime you may have to go lower on this, and vice versa. So that was another point. Let's make this little quick. So types of linked list: single linked list, doubly linked list. So this is just for your knowledge. Let's go to that list what I wanted to show you. So this is the list. So actual use of linked list, I have listed down very few. Actually there are so many. So implementation of stacks and queues. So stacks and queue, actually they are implemented using linked list. Actually you can implement them using array also, but that is not a good, or I don't know, it's debatable. But in older days we use stack and queues, I mean linked list for stack and queues. Okay, and another thing is graph and tree uses adjacency list representation, which uses linked list to store adjacent vertices. Exactly. If you'll see the world of tree and graph, let me draw this very quickly. There is no order of storing any node here, but the point is graph and tree. So leave about the graph, you can consider it is equal. Trees uses adjacency list. So what I mean is, see, one is having 2 and 3. So what they will do, will do, this is your 1, and here comes a list, another list of node what it is pointing to. So this is 2 and 3. Okay, so this is adjacency list. If you are looking for 3, it will be even more bigger. So 3 is the data, 1 2 3 4. So that list would be very bigger. So we have 4 6, maybe 5 and 7. So there is an order to actually maintain this. I'm not talking about that because it will be very deep. So you got the idea, right? One node is actually linked with these many nodes, so you will have linked list, because sometime this 5 may go, or sometime this 3 may go, or sometime this whole thing may go. Okay, go means it might be deleted. So it will be just looking like 1 2 8 10 and 9. So your tree would remain like this. So it is very easy to actually do all these things using linked list and not wasting memory. Actually, you can use vector for this. I've been using vector here for my programming competitions, but this is actually a linked list application. So dynamic memory allocation, OS uses linked list to keep the track. What I mean is that heap I showed you, right, in the beginning, memory pool, that itself contains a linked list way of structuring the pool itself. Okay, that is another thing. You OS uses linked list to loop through all the processes. Yes, that round robin thing, if you remember in your OS class. So let's suppose there are few processes. 1, your music player, 2 3 4, something. Okay, so you know that CPU gives its cycle to each and every process. So how it does that? It actually loops through each and every process continuously, very fast. You cannot see that. Okay, it's like godlike speed, but it loops. It will give maybe some memory cycles here, some memory cycles here, some memory cycle here, some memory cycle here. So you might have seen in older days, if you are old school guy, then if you are opening maybe so many applications in your computer, where computers were not having much memory space, your computer will become eventually very slow. Even nowadays you will experience that. Okay, so that is the reason CPU cannot loop through all those applications very quickly, because there are so many applications running now. So CPU will be maintaining list, not an array, and that is a circular linked list to be precise. And this will actually point to this 1 2 and 3. So if CPU is at this point, maybe after some clock it will be at this point, and now CPU don't have to go back here, actually remember something. No, it will just directly go to the next of this one, and it will point to this first guy. So it's like loop, it will be keep on running. So this is another application of your linked list. I'm giving all these things just because it will be there in your mind, and so many people just know linked list, they don't know the actual use of it. And there are so many things I did not listed that I googled it and I got so many. Even I didn't know so many applications, but I have listed very few because these are the important ones. So okay, this one is done. Next and previous functionality can be implemented using list. Come on, you might have seen a music player where you have a previous and a next button. So previous means you will go to the previous song, next means next song. So that song list is maintained using linked list. So this is the next and this is the previous. So like this, if you are at this position right now. So those things are also using linked list, because it becomes very easy. I mean, you can go with the array, but then it has to be approved by your manager. Okay, and I won't certainly approve that, because tomorrow next song comes and that song is supposed to come here, then I have to shift all these things, right? And I don't want that. I just want to maintain that song in linked list. And in your gallery, in your phone gallery or some gallery, you will do next and previous, and you will have all those images, right? So they are also maintained in linked list. So there are actually so many applications. Now you understood the power of linked list, right? And if you did, don't forget to hit the like button, guys. And I'm completing this video. And if you like this, subscribe to my channel. You will get the notification for upcoming videos like this. I'll see you in the next videos, guys. Bye bye. Take care.